Every single human alive today, all 8 billion of us, descends from a population that may have dropped to fewer than 10,000 people. Some estimates put it closer to 1,000 breeding pairs. That's not a statistic. That's a near-death experience written into your DNA. And here's the part that should genuinely unsettle you. We're not entirely sure what caused it. We have a leading suspect, a volcano, a winter, a collapse that unfolded over generations. But the honest answer is that humanity's closest brush with extinction is still, in places, a scientific mystery. So let's actually dig into what happened, what the evidence says, and why the fact that you exist at all is a far stranger accident than you've ever been told. Let's go. Start with the question most people never think to ask. Why do humans have so little genetic diversity compared to other species? This sounds like a dry technical detail, but it isn't. Chimpanzees, our closest living relatives, show dramatically more genetic variation across their population than humans do, despite there being far fewer chimpanzees on Earth than humans. Gorillas show the same pattern. Even some isolated island bird populations carry more genetic diversity than the entire human species spread across 7 continents. That shouldn't be true. A species with more individuals, spread across more environments, should show more variation, not less. Something happened, something compressed us. Something took a once diverse population and ran it through a bottleneck so narrow that almost everything on the other side of it looks nearly identical, genetically speaking, no matter where on the planet you're standing. Geneticists have a name for this. It's called a population bottleneck, and it's exactly what it sounds like. Imagine a wide river of genetic variation flowing along for hundreds of thousands of years, and then suddenly the channel narrows to almost nothing. Only a fraction of what was flowing before makes it through. Everyone alive afterward descends from that narrow trickle, not the wide river that came before. And once you start looking for the fingerprints of a bottleneck in the human genome, they're everywhere. Studies comparing genetic diversity across human populations consistently point to an event or a series of events that dramatically thinned our numbers sometime between 50,000 and 100,000 years ago. The most cited estimate puts the surviving population somewhere between 3,000 and 10,000 individuals. Some more aggressive models push that number even lower, down toward a few hundred breeding pairs at the tightest point. For context, several endangered species alive today have larger populations than that. So now we get to the actual suspect. In 2025, researchers using coalescent modeling techniques found something that sent a ripple through the field. Analyzing genomic data across multiple human populations, they identified evidence of a severe bottleneck occurring in a window that lines up disturbingly well with one of the most violent geological events in the last million years, a supervolcanic eruption at Toba, on the island of Sumatra in modern-day Indonesia, roughly 74,000 years ago. This wasn't a normal volcanic eruption. Toba was what geologists classify as a VEI8 event, the highest rating on the Volcanic Explosivity Index. For scale, the eruption is estimated to have ejected somewhere around 2,800 cubic kilometers of material into the atmosphere. To put that in perspective, that's enough volcanic material to bury the entire state of California under more than 6 meters of ash. The eruption didn't just devastate the region around it. It punched material directly into the stratosphere, high enough to circulate globally. Once that material reached the stratosphere, it did what volcanic aerosols do. It blocked sunlight. Researchers studying the climatic aftermath have proposed a volcanic winter that may have lasted years, with some estimates suggesting global temperatures dropped by several degrees Celsius for an extended period afterward. A drop like that doesn't sound dramatic until you understand what it does to an ecosystem that depends on predictable growing seasons. Plant life collapses. herbivore populations that depend on that plant life collapse behind it, and the predators, including a small, clever bipedal primate with no fur, no claws, and a diet that depended entirely on that same collapsing food web, would have been staring down a catastrophe with no modern equivalent to compare it to. Here's where the story gets genuinely uncomfortable, because this is where scientific consensus actually breaks down, and the honest answer involves real disagreement. For years, the Toba catastrophe theory, first proposed by researchers including Stanley Ambrose in the 1990s, was treated as the leading explanation for the human genetic bottleneck. The timing lined up. The scale of the eruption lined up. It was a clean, dramatic story. One eruption, one winter, one near-extinction event. But more recent archaeological evidence has complicated that clean narrative considerably. Excavations at sites in southern Africa, including Pinnacle Point, have found human occupation layers directly above and below the Toba ash deposit, showing continuous tool use and apparently minimal disruption to at least some human populations during the exact window when the eruption should have been at its most devastating. That doesn't mean Toba didn't matter. It means the picture is messier than a single clean apocalypse story, and some of the populations closest to the epicenter may have fared very differently from populations further away in different ecosystems with different resource bases to fall back on. This is genuinely one of the more fascinating parts of the whole mystery because it suggests the bottleneck itself may not have been one single dramatic event at all. Some researchers now argue the genetic evidence is better explained by a longer, slower squeeze. Multiple glacial periods, repeated climate stress, and chronic resource scarcity stretched out over tens of thousands of years, rather than one volcano delivering a single knockout blow. Under this model, Toba may have been one severe stressor among several, a brutal but not solely decisive chapter in a much longer story of a species barely holding on across an unstable, unpredictable world. Both explanations, the sudden catastrophe model and the slow squeeze model, are still actively debated in the literature, and the honest scientific answer right now is that we don't have full certainty on which one or what combination of both actually produced the bottleneck we can see written in our genes today. What we do have certainty about is the aftermath, because the genetic evidence for what happened after the bottleneck is remarkably consistent no matter which cause you favor. When a population drops that low, something called a founder effect kicks in. The surviving individuals, whoever they happen to be, become the genetic template for every single person who comes after them. Traits, mutations, and variations that existed in the wider pre-bottleneck population but weren't present in the surviving group simply vanish. Not because they were bad traits, not because natural selection weeded them out deliberately. They vanish because the people who carried them didn't happen to be among the small group that made it through. That's the part that should genuinely sit with you for a second. The specific humans who happened to survive whatever this event or sequence of events actually was, didn't survive because they were the fittest, the smartest, or the most capable. In many bottleneck scenarios, survival is closer to a lottery than a competition. Being in the right valley, near the right water source, with the right local conditions, mattered more than almost anything else. You are here, reading this because a specific, narrow, almost arbitrary slice of humanity happened to make it through a filter that most of the population around them did not. This is why human genetic diversity looks the way it does today. It's why researchers studying the human genome consistently find that two people born on opposite sides of the planet, different continents, different appearances, different languages, are, at the genetic level, remarkably similar compared to two chimpanzees living in neighboring valleys of the same forest. We look different on the surface because a small number of highly visible traits, skin tone, hair texture, facial structure, adapted relatively quickly to local environments after populations spread out from the bottleneck. But underneath that surface variation, the deep genetic diversity that should exist in a species our size, spread across our range for as long as we've been around, simply isn't there. It got filtered out somewhere between 50,000 and 100,000 years ago, and it never fully came back. There's a broader pattern worth sitting with here, because humanity is not the only species carrying the fingerprints of a near miss. Cheetahs today show such extraordinarily low genetic diversity that skin grafts between unrelated cheetahs are accepted without immune rejection, something that would trigger a severe reaction in almost any other mammal. Researchers trace this back to a bottleneck event roughly 10,000 to 12,000 years ago that may have reduced the species to a small handful of survivors. Northern elephant seals show a similar signature, tied to hunting pressure, that pushed the species down to an estimated 20 individuals in the late 1800s before conservation efforts allowed a recovery. In both cases, the bottleneck isn't a footnote in the species' history. It's a defining event, still visible in the genome of every individual alive today, generations later. Humanity's bottleneck is simply older, larger in scale, and tangled up with a much longer and more contested list of possible causes. So here's what this actually means. Once you step back from the volcano and the ash and the disputed timelines, you are not the product of an unbroken, uninterrupted evolutionary success story stretching back millions of years. You are the product of a species that came astonishingly close to disappearing entirely for reasons we still don't fully agree on, survived by a population small enough that today it would qualify as critically endangered by modern conservation standards, and then spent the next 70,000 years rebuilding an entire planet's worth of humanity from that narrow, uncertain foundation. Every language ever spoken, every civilization ever built, every person who has ever lived, all of it traces back through that bottleneck, through a group of humans who had no idea they were the thread the entire future of the species was hanging on. Next time someone tells you humanity's dominance was inevitable, that we were always destined to end up here, remember this. There was a window somewhere between 50,000 and 100,000 years ago when the entire future of our species may have depended on a few thousand people, possibly fewer, figuring out how to survive one more season in a world that had turned against them. They didn't know they were the bottleneck. They just knew they were cold and hungry and that tomorrow wasn't guaranteed. And somehow they made it through anyway. That's not destiny. That's the thinnest possible thread of survival, and you are standing on the other end of it.